Hi, everybody. I'm Bunnie. I design hardware. I have a small sort of boutique design studio in Singapore. I've been making all kinds of weird hardware for a very long time. Um, Last sort of decade or so, decade and a half, I've been trying to figure out how to scale up ideas. So, go from what was just like little solder prototypes on my desk to trying to produce things not necessarily at a big scale, but at a bigger scale than I could make on my own desk. And so the sort of the nut that had been trying to crack, and I think I've managed to at least find an angle on it, is how do I build 100 of something in injection molded cases and have it done at like a reasonable price or something like that. So that's kind of you know and then now we're sort of looking at other things like how we build test jigs efficiently, how do we scale that up, a bunch of sort of small logistics issues. And I have some background now in mechanical design, a little background in industrial design, a little background in software, a little bit of everything. So I'm looking forward to sort of hearing you guys' projects. I do also spend some time also mentoring for Hacks, which is an incubator in Shenzhen, and helping out at the MIT Media Lab. Hopefully a little bit of my experience helping review those companies as well can benefit here in this context. I think that's enough about me.
Awesome. Thank you, Bunnie. All right. So since the agenda got changed a little bit by the request, do we have any volunteers for who wants to go first? Who's here? Next, we're going to talk with the members of Funky. It looks like they've joined us. We have, you guys want to introduce yourself?
Both of us, me and Vincent. Maybe Vincent, you will start with a small presentation of the prototype. We cannot hear you.
Hi everyone, can you hear me now?
Yes.
Yeah.
Much better.
So we've run into a bit of Moore's law, and the prototype's not working today because this morning it decided not to work anymore because right now, this is the prototype.
Mm-hmm.
So it's actually, I don't know if you know on what it's based, but basically the first one was built 3 years ago, and it's called QEMU, and it was this. I don't know if you followed the project. So basically, maybe you're familiar with Sprite TM.
Sprite TM.
He's a well-known hacker, and he's
yeah, it's a brilliant hacker.
Yeah.
Okay.
You know him? All right. So basically, 3 years ago, at the Hackaday Super Conference, he every time he shows something amazing. Every time he shows something that he's built during the year.
Yeah.
3 years ago, he's built. I remember he had a Game Boy on his keychain, but it was just showing the time it was just an old Game Boy showing the time, and he decided to build one that could actually be playable, on which you could actually play. And he built it and he showed it to everyone. And actually, it was a bit crazy at the time because people were just watching him playing on his tiny Game Boy.
Mm-hmm.
And he said that everything was going to be open source. And at the time, I didn't know much about electronics, and I wanted to build my own because I found this very nice, cute, and it was a great project. And so I built this, and it's completely rethought because I didn't find the code or anything from SpriteTM at the time. So we built this from a different kind of module. It was the Intel Edison module. I don't know if you remember this.
Edison. Mm-hmm.
Yeah.
Yeah. So it's built on the Intel Edison, and so it's basically it's really small, and it's actually quite the same size as the one he's built, but with multiple emulators on it, and actually the screen is way bigger because the form factor is actually foldable. So since you can fold it and open it, you have a way bigger screen than his. Actually, let me show you. So this is the form factor that SpriteTM came up with 3 years ago. And maybe you've seen this. It's called the Pocket Sprite. Maybe you've heard about this. So he built one 3 years ago, made out of, it was a prototype, and just, it went crazy, and some people wanted it. And so he went through with it. He went to production with it. And he actually came up with this, which is the Pocket Sprite.
Cool.
And we came up with this 1 year after the first one because we were inspired by the one he showed at the conference. And this small thing, which actually worked great at the time with the Intel Edison, got a lot of
attraction.
And I'm sorry?
A lot of attraction and a lot of views on YouTube.
Yeah,
Yeah.
sure.
And for us, it was, I mean, we liked it. It was, what can I say? I mean, it was, for us, a great project to learn and see things. And we didn't expect this. And we were happy to see that so many people wanted to build their own. And we, of course, all the code was available. Everything was available. And I made tutorials so that people could build their own. But sometimes people don't want to build everything from scratch with this. And of course, now the Edison is discontinued, so you can't find it anymore, so you can't build it anymore. And so we have like one YouTube video with 4.5 million views of people asking to buy one. So we said, okay, we are going to go into production with it. But from the prototype to production, there's a, I mean, we realized how much of a world of difference there is between the two. So basically with this, we can't do much apart from, I mean, it's, you can't see it, but it's just, it's painted. It's not really well made. Of course, it's not fit for production. So we had to make a lot of changes. We had to change the processor because the Intel Edison is discontinued, and we had to adapt things, and we had to rethink of the hinge, for example, because the hinge now, with this, it was folding the flex the flex PCB, and so basically after a few openings and closing, it was unusable anymore.
Right. Okay.
So we've rethought everything, and we've rethought everything now with a mechanical engineer which is not here today, which is David, and he couldn't be here, but he's thought about a lot of things for us, and we've rethought about new things with production in mind. And now we came up with this one. And now it's like a foldable phone. It's smaller. It's actually a better screen, better resolution, and it's cheaper as well. It's now based on a processor from Allwinner, the V3S. Maybe you know about the processor. And so that's it. So right now, Michel, you can tell a bit more about it, about where we are right now, and why we wanted to be here today, because we wanted to talk with you and ask you many things about now the steps that we should take, and because you know these kind of things, we know you, so we wanted to ask you a lot of questions about this.
Sure. Yeah. What's the first thing on
that? I will just continue on that. I will just show you what is the exact board right now. Trying to find, yes, here it is. This is the PCB that we have. This is still a prototype. But it's something really, it's a revision A. We are working on revision B. This is all soldered by hand, actually using a reflow oven, but it's not something industrial yet. It's not been done by a separate company. We soldered all the components by hand. And we also have design, case design, which is 3D printed right now. But as you can see, this is there are a lot of details in it, and it's almost ready for production. I mean, from this design, we can almost go to have a mold done for us.
It does look mold ready. Yeah,
it is.
So the main problem that we have a PCB. I can show you what it's like. Maybe if I can find the way to do it into the application. Yes. Okay. Here it is. You see in 3D, it's in KiCad. So we have in step, and all the Gerber files ready, and everything is ready yet. We have the same thing for the mechanical CAD. And we are at the point where we wonder how can we go the next step. I mean, we have a nice prototype that is working. We are still working on the software. It's a software based on Buildroot, so we are creating the kernel and everything from scratch. And this is something that we are used to. But the problem that we have is to find the resources to get into an industrialized
Process.
That's something we don't know how. From now, we'd like to get in touch with some companies, probably in Shenzhen or in China, to get the PCBA done for us, because I don't want you to solder all the PCBA by hand. And at least for some prototypes, like half a dozen, boards to get them done and to check if there are some issues with the industrial PCBA process, and to get the mold done. And this is something that we need at least to have an idea of the budget to do that. What we plan to do is to launch a Kickstarter campaign as soon as we have an idea of the budget for producing these devices.
And it's 90 of the budget? What do you mean? As soon as you have what? 90? What? Well, I didn't quite understand. You said as soon as you have what of your budget? An idea of the budget.
An idea.
An idea of the budget.
You said 90 of the budget, like 90.
No, the budget. The budget. We need an idea for the PCBA. We need an idea of the test for the test, packaging, enclosure with.
Basically, you know what the cost is, so you know what to ask for to get it produced, right? So you need some quotes from a factory to make it happen, right?
So we don't have any contact with companies that can help us to do that. That's our problem. So this is basically what we are now.
And also we don't want to miss any costs. For example, if we start counting the BOM and everything, and we're missing something, and then later we didn't ask for enough, and we get stuck.
Yeah, it's deadly. Yeah, it's totally. That's why you put a margin on your design. So,
yes.
But how you want to make money? Like half the time you don't make it because you didn't put enough margin in because you had something happen that you didn't expect, right? So
that's
not just greed.
That's what we don't want.
No, put a margin on there. Jesus Christ. I mean, God, this could be like a 5-hour conversation. I've got 2 minutes to tell you to give you some advice. So first of all,
take 5 minutes, and we'll cut a little bit out at the end just to see.
Thank
you.
So I think that you guys are definitely ready at the point where you can start engaging contract manufacturers. The question is, how much do you guys want to get your hands dirty dealing with the factory, or how much do you want to just pay money and just have someone else deal with it, right? So the reason why I say this is there are people who are relatively expensive. They'll charge a fairly large markup, right? But largely they can take it from this point, and they would just help you with the production of things, right? But it's going to add 20-30% to the cost or something. They're going to charge a fairly large fee plus some other overhead for it. Versus if you guys want to literally go out to the factories yourself and you're excited to spend some time in the factory, it doesn't have to be in Shenzhen. There's a lot of options around the world you can go to. I can tell from your accent, sounds like you guys are from Europe. There's some strong manufacturing in Europe as well that you can go to. The injection molding probably done in China, but that's manageable. There's a pretty well defined process for that. But when you do the actual system integration, you're going to have to basically pick a prime contractor, what I would call, who essentially they manage your entire BOM, right? Your bill of materials, and they'll be the one who you want to sort of say, okay, here's the plastics design, go source some molds here for that. Here's the parts, go buy those. Here's the gift box. Here's the instruction manual. You guys are gonna have to get FCC CE certification, so you might have to work with them for these sorts of things. You're gonna have to deal with, if you have a lithium battery in there, you have to deal with UN 38.3 certification. There's a whole bunch of stuff that has to come together, right? And
who could be the one that, for example, is there a company or something that they take us by the hand for knowing all these things? For example, they would say, okay, for this certification you should go there, and for this certification you need this.
So the good news is that there, upon the corpses of 1,000 people rises civilization. There's a lot of startups who failed, and a lot of companies who've been burned by startups who have failed, and so they've learned, right? So the good news is there's actually now kind of companies, more and more companies in China and around the world who who are prepared to give you the guidance that you need to do this. About 10 years ago, it would have been really hard. Now there's people who kind of know how to do this. You know, one of the companies I work with all the time, their name is AQS. They're sort of a full service group. They have injection molding facilities. They have a PCB manufacturing. They have links to printers. And so I do a lot of my products with them. That would be like a typical example, but there's other ones as well. I mean, there's actually a bunch of companies are starting to get pretty hungry. The trade war has sort of really impacted the business levels, and so it's a little more competitive, I think, to sort of get in with these companies. You have a bunch of options, basically, is what I'm saying. So probably you should quote at least 3 or 4 different facilities. You'll probably find some are very high, some are very low. And the reason why a lot of times is the amount of service that they will give you along the way as well, right? So it's not just about the bottom dollar that you get. Like if that company will also do some DFM for you, they have some value-added engineering on the inside. So probably when you hand off, for example, your 3D models for production, they're going to change a little bit. They're going to change the draft angles, they're going to change the parting lines, they're going to put some bosses and features in there to keep it from warping when it comes out of the mold and plastic. Someone needs to do that. That has to happen. And so the question is, will they be able to add that value, and is that part of the margin they're charging? Versus another company who would just say, sure, we'll just throw in the mold, see what comes out. And you're like, why does this look like crap? It's all like warped and like there's like shrink marks all over it. It's called like you knew what you're doing. So
yeah.
Go ahead.
No, okay, please continue. Sorry, I was going to cut you and ask you something else, but I'm going to ask a bit later.
No, go ahead and ask. We're short in time, so.
Okay, so let's say we find a company that's ready for us and that's right for us, and so they're ready to take us the whole way. When should we do that? I mean, should we first have the first firmware kind of finished, or should we wait till we have something that we tested already?
You guys are ready to look now. You should start. And the reason why I say you should look now is because it takes a while for you to negotiate the relationship, right? So what's going to happen? You have a bomb. It looks like you're about like 90% fixing your bomb. You have your mechanical bomb. You need to tie down some details, like what are your accessories, and like just like the way I do this is I imagine I'll mock up a whole thing as if I were to got it from the retail. And as I put them in, I would take it all apart. I'm like, oh, there's a box, there's a plastic bag, there's these screws, and so I make sure nothing gets bit from the bomb, right?
Sure.
And then,
bomb,
right, it's going to take you like months, couple months, 3 months or something like this to go through that whole sort of process of quoting and figuring out, visiting, qualifying, that sort of stuff. And then even after that's done, even after you have that, like to buy the parts, a lot of parts, they have lead times on the order of like 12, 16 weeks. That's another 3 to 4 months you have to wait for the parts to even come in stock. So the thing is, like, your firmware is probably going to be done, I'm guessing, in like
by the time,
in the meantime. And the one thing that you do want to think about now, finals up from everything, is you should be responsible for making the final test. Don't hand that off to the factory, right? So but at this point in time, think about how you're going to get the firmware on there, how you're going to qualify the units, how you're going to make sure that everything on that works. All the buttons, the screen, the hinge, the power brick that comes with it, everything has to be tested. So you have to come up with a test infrastructure for that. They'll save you a lot of time later on, a lot of pain, because that's where you catch the factory defects, and that's where you make sure your customers aren't unhappy.
So you're talking about the production software, so basically making the jigs even and the software and everything for production. So this for that, we don't have anything, and so if we start looking for people and ask them about the BOM and how much it costs and everything, if we start now, for example, that's what scares me a bit. It's like we don't have anything for production software, so we're not ready.
So what will happen is the company can probably take a reasonable look at your thing and say, this is about what it's going to cost to test it based upon, like, if you do, even if you just write out a plan, you say, we're going to put firmware in it, we're going to press the buttons, we're going to, like, you can just even like there, you can say, okay, and this will take 5 minutes, 10 minutes. The thing is that one thing that can solve the production time is that you have parallelism. You buy more test jigs, you throw more people at it, right? So that's, there's a, like, the throughput can be solved. There's a bunch of things you can do. And what you'll find is that when you engage with a company who's going to do it, what you should ask is you should say, hey, we need to build the test firmware for this. We can do that, but we need your support to build the physical test jig itself. And I guarantee you, they will have a vendor who can build the pogo pin thing, build the thing with, like, you should waste no time building that jig itself, the physical jig itself. It's all about the firmware. The firmware is the really hard part, and you guys are the only ones who know all the details and all the gotchas. Because the thing is, that it's really tempting to say, oh, hey, they built these wonderful test jigs, just have them do it. They'll do the minimal tests. They'll like turn it on, measure current, and say, okay, didn't smoke, okay, ship it, right? That's not good enough.
All right, that's good advice, thanks. Okay. All right, do you have any other question, Michel?
I'm sorry, you guys, we have to move on.
Okay.
Okay. I was like, they're asking questions like 5 hours to answer. So.
Yep. All right, so coffee stirrer team. I believe that's Rupin. Are you here?
Hi.
All right, Rupin. And if you can make the intro part of your description pretty brief and get to the specific questions you have, I think that'll help us be as productive as possible.
I can see your page in Hackaday, so I have a general idea of what you're trying to do.
Okay. So I'll go directly to what I built by now. What I'm trying to solve is when you drink tea or coffee, you take the first sip and you know it's too hot and you get singed. So what I built, I built a proto, and you can see that I've dipped it into tea, and I figured out that there are a couple of LEDs. Then I went to a point where I removed something, added something, ended up making my first proto. This is what it looks like. That's really tiny. So I really have a couple of questions. I'm not as far as I would think that I want to start big scale manufacturing. What I want to figure out is that when somebody puts this into their tea or coffee, it'll require them to clean it because you have to put it back in your bag. So how do you, I'm thinking that it'll be in the form factor of a stirrer. And what material do I choose? I'm thinking I'll go with stainless steel as the base of the stirrer, wherein it can conduct the heat back to the sensor. And the top of the product will be just this. The other idea I'm having is to use glass. Like, how do you use that in a thermometer? Because this essentially is a thermometer. So that's one of the things. The other one is if you can guide me better sensors, I'm using a run-of-the-mill TS18B20. But then if there is a lower power temperature sensor, a better temperature sensor, I don't need very high amounts of accuracy. All I need is to know the first 2 digits of the temperature. I don't even need the decimal points.
Yeah. So I'm going to throw a couple of just things on the wall, and we'll see what sticks. So first of all, one thing you can do from the form factor, I know this is a big pivot from what you're doing right now, but there's a sensor called a thermopile. It's a non-contact infrared sensor. So that solves the food safety issue, the encasing issue, right? And a bunch of stuff. I haven't priced one out, but I know that there's a little tiny, it's like a little WLCSB, I think it's made by TI. You put it on a board and it just senses temperature. It's like magic, right? So you might want to think about a non-contact method, because that way you solve like the cleaning problem or whatever it is. If you do decide to go with the contact method, I think the biggest problem you're going to have is you need to deal with some food safety issues. Like, it needs to be like, not just like any stainless steel obviously can be food safe, but then like I think the processing and the handling of it, you want to make sure that there's no contamination of industrial oils that are left on it. There's some complications in it. There's some food safe plastics you can use as well. So there's polyethylene and a bunch of other stuff that can be like molded into a shape that you need. The stainless steel idea might work. The problem is in a bit is that you kind of have to put the sensor at the tip and then run a wire up, and so there's going to be like a bit of an assembly challenge in getting that. If the thing that I would actually almost suggest you do is, those thermometers that you put in your mouth just to take your body temperature? those things, like, get one of those and take it apart, right? And they'll actually give you a really good idea of, like, because they have to solve all of the problems you're trying to solve and more, because it's actually sort of a medical diagnostic device. That'll give you some ideas. And so some of the clues on how those things work is that I think they don't even necessarily wait until the temperature equilibrates. What they do is they model it as like there's an RC sort of time constant for the temperature goes up, and they sort of see what that is from the base temperature, and they can interpolate where the final temperature will be. So they don't actually wait like the 2 minutes.
The final temperature.
Yeah, to actually get there, they can actually, there's a well-known curve they can so you can actually, so there's a lot of really cheap sensors you can use. There's some very simple like thermistors, just like resistive.
Yeah, the ones that go in the 3D printer.
Yeah. Or like a little, there's also like a diode. A diode actually works as a great temperature sensor, very, very cheap. And the trick there is just getting a calibration on it, so that, but you only need to be a few degrees, so you may not even need to
not too accurate.
Yeah. So there's a lot of pretty cheap options there. I think the main thing is think first about think first from the user experience. I think a thermopile will be a better experience than a thing you have to clean and do that sort of stuff. It may cost more to do a thermopile at the end of the day, but once you consider like the cost of the food safety and then the cleaning and the convenience, that sort of stuff, that might be a better user experience. So maybe consider. I don't mean to like throw you off your track, right?
Yeah.
Think about that. The other thing I noticed is that it looks like you're using like an Tiny and a couple other things. Those are not the lowest power microcontrollers out there. There's some lower power ones like the TI MSP 30 is pretty legendary for like being perfect for the low power situation. I saw that you put like a FET to go ahead and gate the power on your things. You're going to be doing a lot of that. Also, if you can avoid shipping a lithium battery, avoid shipping a lithium battery. Like it will, like in terms of like just logistics and headaches, like there's like a whole set of certifications and crap you have to go through, and then like when you have to do a lot of testing, because like for example, lithium batteries can get in a state where they're so deeply discharged, there's a protection that cuts them out, and then like you have to like have a little circuit that puts a little bit of energy in to turn it on to get it back out of that state. Otherwise, it looks like it's bricked and it's dead, and you have return. And like there's all these complicated states with lithium batteries. Whereas if you have like the coin cell, you just replace. It's, you know, if it doesn't work, they throw away, put it in. It's a less engineering effort for you. It's less risk. Particularly if you can ship it with the coin cell separate and there's no lithium at all, then you can get through. Like there's no restrictions on shipping, right? But like you'll find that as you scale up, like lithium will be like just such a, because you can't put lithium on a commercial plane in bulk, right? I mean, like, you know, if like passengers are riding it, but that's oftentimes the cheapest way to get stuff around is like cargo takes, you know, a seat underneath the plane. Then you can only go on the dedicated just bulk, you know, shipping planes, and so there's a higher cost you have to pay to ship lithium on the inside. So, and probably if your product is going to go where it goes, you're looking for something that's quite cheap, and you'd be falling back into like logistics as being like a driving cost, your cost all the way down. So those are just some things to think about maybe as you.
So I have one last question. So how do you actually validate the idea? Is it something people will use, not use? I'm wondering, I'll do field tests. Like I'll go to a coffee shop, whatever the customers are there, I'll just ask them to try it out. Or I ask the people who are actually giving out the coffee to give this complimentary for that use only, to return it after they're done. What other ideas do you have? If I could try.
I mean, this is, I'm not a designer. We have a designer on the call, actually. You can answer better. But you know, I find that like it's important to not drink your own Kool-Aid too much. So it is important to get advice, but you also have to be aware of who you're getting your advice from, right? So if you ask a particular type of coffee drinker or a particular demographic, you will get a type of advice, and you have to be a little careful not to take too much out of like.
Not to read too much into it.
But a lot of it is just sort of thinking, like you immediately identified the issue of having to clean it, right? That's an inconvenience, and so then you say, okay, well, how can we make that experience better? So it's a lot about how do you make these experiences, you know, better at the end of the day. I mean, it could almost be like if you could find a way to take like an existing smartphone and build a thing that like just interpolates temperature based upon
From the
some
camera.
other thing, like that would be like a really great experience, because now it's just an app that people can install and pay you for it, right? Like,
Right.
like there's like a multitude. There's a big space of things you can do. And I mean, another one could just, I mean, not to just completely throw it, but like, they have those little like stickers that can like change color when they
Yeah.
when
When
they
you can just wrap it around the coffee cup.
wrap it on a coffee cup, or you can make a disposable stick that has that on it.
Yeah.
You stick it in there, you wipe it off, and that's super cheap.
Yeah.
That's 15 cents, and then you just
Yeah.
put it in, take it out, wipe it off, and you see what temperature. Like there's a lot of options you
Different
have.
ways of doing it. Yeah.
Right. So I don't mean to like, I
Yeah.
think I see what you're trying to do, but just open your mind and just think about the experience.
Other ideas.
And don't try to over-engineer the solution.
Okay.
Yeah.
All right. Perfect. Thank you.
Yep. Magenta, are you there?
Thank you, Rupin. Sorry, my thing was muted. Okay.
Thank you.
Last but not least, Abhishek, you have Phalange Pad. So
Yeah.
Bunnie can see your project. He has them open on his computer. So if you're able to get to the questions you have for him, that'll be the most productive way to use the time we have.
Sure. So the idea that I wanted to ask mostly was that right now I've been thinking of an approach of using capacitive flex sensors. Basically, the idea being that you just press your thumb against the phalanges of your fingers, so you can basically type this way.
Right.
Sort of.
Mm-hmm.
Yeah, that's the idea. So right now, the approach that I was thinking of was to put a piece of flex on the inner edge of the fingers,
Mm-hmm.
and then try to read the just try to read the capacitive output and get it. So as of now, I've got some Kapton tape and some copper foil. So this weekend I'll be building and trying it out to see how it works with a team fee. But but is there anything else I could try? Like, for example, I've seen on the internet a few examples where they put a magnet on the finger and hall sensors on the fingers, hall sensor on the other finger. But this just works for one particular finger.
Mm-hmm.
And so it's more like if not capacitive, what else would I use? Because in capacitive, there would also be the issue that because this is already resting against a finger, so there will be some baseline reading that I would probably get, and I have to subtract from.
Of course. Yeah.
Actually get my thumb reading. So what is your feeling about this approach, and how do you think this would work?
I think so. The tricky part here is, I guess you're imagining you're gonna turn this into a glove, I guess, that someone wears. Like, what's the thing look like at the end of the day?
So I don't actually want to make it like a glove because like it's not something that like my ultimate idea was that it's not something you have to wear. You just do it like barehanded and you should be able to get it. But to get to that point is kind of a bit difficult. So what I was trying to just get to is like a simple thing just covering the fingers, and you wear it like a glove, but it's not actually a glove.
A thing that just like it's like an exoskeleton you stick on there, or like
a piece of flex, but I assume that would not be very durable. But initial, if you see one of the project logs, I talked about a piece of flex PCB that I then fold on the edges, and basically it becomes a ring on the fingers. But then there's a whole strip that's there. So I was assuming to make the first thing I would make is something that like a flex PCB that actually fits all 5 fingers.
Yeah,
Like
I see. Yeah, I mean, I think again, like one of the really key things to think about first is actually what are the ergonomics of what you're trying to build, right? So when I said it's like a glove, the idea is that you just slip it on and it's easy to go, or if you have to have something go on each finger, that's actually much harder to put on, or you grabbing an object that is doing it. So that's a question, like you need to, ideally it's a very like a simple thing to do. So like gloves are nice and simple because you just slip them on and take them off, right? And then so if you're going, let's just say for a minute you're going for that form factor, right? It may be the case that you can simplify the problem. I know the problem you have about the baselining of the passive touch. If it is a glove, the thing you have the advantage of is that you now have your thumb. You can also turn into an active emitter, so you can put a frequency on it that when it comes close to the particular things, you can actually check for the coupling level. So you can put a test like just tone on it or a modulated signal, and then when you the electrode that's closest to will get the strongest reading of that. So you can do like a synchronous rectifier or something like that on the other side to go ahead and pull that reading out, and that solves the baselining problem because now you have it's essentially an active touch system. But maybe even better way to do it is if you can find, and this would be better and thinner, is that if you can find a way to put conductive thread into a glove, so they can make conductive thread for like the ESD smocks, right?
okay.
The idea is that if you can make it so that you have a conductive thread along here, right? And you have conductive thread here, you may be able to make it so that you can tell where you're touching by the contact of the thread along the region, and the variation of the resistance. Of course, it'll depend upon how much pressure you put on it and stuff like that. So maybe that's not a great idea. But like that would be the reason why I say is it's a more comfortable thing than trying to put your finger through like a ring of flex. And the ring of flex itself, the problem is not all fingers are the same diameter. So it's either going to be too big for some people or too small for some people. So that can be a big complication. And the integration of the flex into the glove itself can be actually a non-trivial problem. And the other way, if you're looking to do something like this, I know this might be a little bit out there, but another way you can do it, and I think I might have seen this a similar concept to this, is someone had built like a watch that you wear here, and then there's like a camera that actually points down here, and they actually do it by vision to see the flexing of your fingers and where your fingers.
Okay.
So you can do like a gesture-based thing based upon a camera. Like it's a little weird, but it's like a little thing with a little like a camera that sort of points down here, and you can go ahead and use actually vision. So there's actually no glove at all. It's just like a thing you wear on your wrist, and then it sort of feeds it. Like has a. I mean, the problem is, of course, is you need a big computer with vision and stuff like that, and then you have to connect it to stuff. But like so that maybe these aren't great directions, but there's sort of some things to think about in terms of like form factor in trying to accomplish your goal.
Yeah. In terms of the hardware I'm trying to use, like PC, I know would be a good starting point, but do you have any recommendations on what kind of hardware or what kind of like capacitive sensing chips or anything that you have worked with or any part that you know of could help here?
I mean, there's a lot of sort of cap touch devices in there. Yeah, but the problem is a lot of the projected ones would have the baselining problem that you talk about. But if you can make it so that like the thumb is has a ground plane, like a well-wired electrical ground plane on it, that may help solve the issue you have with the baselining. Atmel actually does have, they are pretty strong in the touch space, so you're probably looking in the right area. They have some like very specific touch products that they make. I mean, they're basically their existing Atmel line with firmware on it that makes them do the touch algorithm, right? And so that's probably a reasonable starting point. There's another competing, I can't, the name of them slips my head right now, but there's another company that I go to when I look for touch solutions. As well, but you can Google it. There's like a couple of like kind of big touch providers out there that you can look to. Another option is actually they have force sensitive resistors, FSRs,
Okay.
So you can put force sensitive resistors in the pad themselves. So then you're not even doing cap touch at that point in time. There's no baselining issue at all. The main issue with the FSRs is they're a little bit expensive, but with the FSRs you solve the baselining problem entirely. You don't have to put a ring around. You can actually just put pads like along the length here and then just touch them, right? So
Yeah, I see. Yeah. So I guess that'll be all from my side now. So anything else you want to say about the project or the idea, or any comments or anything you have?
Yeah, I mean, I guess there's a keyboard that I'm familiar with from a long time ago called the Twiddler. Have you heard of it? It's like a mechanical. It's actually you pick it up and it's a chord keyboard that you type with like one hand. That is, it's one-handed typing. I'd suggest you have a look at that just to get a little more intuition for the user interaction dynamics of like one-handed typing and using chords and that sort of stuff. That might be just getting one and learning a little more about that user experience would probably help inform your design direction a little more. I think it's really important to think about. I understand the route where you came up with the idea of the problem, but now this is the challenge is how do you turn that around into a wonderful user experience, something that's like delightful, easy to use, that's fun, even, right? I think that would be the key thing. So
Yeah. Okay. Thanks. I'll check it out. Yeah.
Okay.
Thank you so much.